Welcome to the 2018 FRQ exam for AP Statistics. In this video, we're going to go over question number 1, explaining what the question is and all the details on how to solve it. All right, so let's just dive right into what the question is. The manager of a grocery store selected a random sample of 11 customers to investigate the relationship between the number of customers in a checkout line and the time it takes to finish checkout. As soon as the selected customer entered the end of a checkout line, data were recorded on the number of customers in line who were in front of the selected customer and in time, in seconds, until the selected customer was finished with the checkout. So basically, they grabbed a random customer, they counted how many people were in front of that person in the checkout line, and then they also recorded how long it took until the selected person finished with their checkout. And you would assume, before even we look at the data, that if there's more people in front of you, the longer it's going to take for you to check out. Now, the data are shown in the following scatter plot, along with the corresponding least squares regression line and the computer output. So when we are looking at two variables, two different values, two different quantitative variables from a single person, we can create a scatter plot. So every one of these dots represents the number of customers that were in front of that person, and how long it took in seconds for the selected person to end up checking out. So we see the scatter plot, we see a line of best fit through it, and we also see one of these computer regression outputs. So this is an output model that could give us all of the information we need to know on the line of best fit, which is what we call in statistics world the least squares regression line. All right, so let's just dive right into everything we know. We know the X variable is the customers in line. We know the Y variable, that should be next there. The Y variable is the time it takes to finish checking out in seconds. Now down here, there's a lot of great information, so let's just talk about it. The first column goes in alphabetical order, A and then B. A is your y-intercept, B is the slope, so I can actually write the regression equation here. So it'd be A, 72.95 plus 174.40 times x. This right here is the standard error for the slope and the standard error for the y-intercept. This is the t-score for the slope and the y-intercept. And here are the p-values. And then down below we have the standard deviation of the residuals. We have our r squared value, and we have what's called r squared adjusted, which in AP statistics we don't ever use. All right, so that's everything that we see in front of us. Maybe we're going to need it, maybe we won't. Let's take a look at the questions. All right, the first question says, identify and interpret in context the estimate of the intercept for the least squares regression line. The intercept, that's the y-intercept. That is your A value, which is right next to the word constant. And there it is. There it is. That's how simple it is. Again, remember A and B. So all you got to remember is A is the y-intercept, B is the slope. And if you had a good teacher, you should know that. Now, first I wanted me to identify. So I identified that the intercept is 72.95. How easy was that? Then it wanted me to also interpret what that value means in context. So a y-intercept generically is what happens to y when x is 0. So in context, that means if the selected customer has no one in front of them, 0 people in front of them in line, because remember, in this problem, x is the number of customers in front of the person. So if nobody's in front of you in line, that's a value of 0, then the estimated y value would be the time it takes for you to finish checking out, and that's the 72.95 seconds. So once again, nobody's in front of me in line. It's estimated, it's predicted that it takes me 72.95 seconds to check out. Now, this particular question did not ask about slope, which is kind of shocking to me because I'll be quite honest, usually we do ask you about slope. This question did not. So I thought it'd be worth it real quick to just talk about the slope and what the interpretation of the slope would be in context. So if this question did ask you about the slope, that is the B value, 174.40, and the slope is how much we predict the Y to change for each increase of 1x. So what I like to do with slope is I write it as a fraction, so 174.40 over 1. When you think about slope, maybe back from algebra class, it's always rise, which is the change in your y's over the change in your x's. X's is the number of customers in line. Y well, actually it'd be y hat because the line is for predictions. The predicted y would be the predicted time to check out. So this tells me that for every one additional person that is in front of me in line, it is predicted it will take an additional 174.40 seconds for me to check out. So more people in line, more seconds it's going to take. So that would be the interpretation of the slope. Even though that wasn't asked, I thought it was important to go over. Then it wanted me to identify and interpret in context the coefficient, of determination, r squared. So here is the r squared value. It's literally r squared. So if you know about r is correlation. If you take the correlation squared, you get r squared. Now, this is a really cool number because it basically tells you how, for lack of a better word here, how interconnected these two variables are, number of people in line in front of you, and the time it takes to check out. So here's how we say it, though. It's got to be said a very specific way. The value is 73.33%. This value tells me that 73.33% of the variability in the time it takes a selected customer to finish checking out is explained by the variability in the number of customers that are in front of them. So in our data, we had different numbers of customers in front of people, right? Sometimes there's 1, 0, 2, 4, whatever. And we also had different times to check out. So the r squared is actually telling us the percentage of the variability in times to check out that are actually because of the variability in the number of customers in front of you. Now, 73.33 is a fairly strong value, obviously closer to 100%. The tighter the connection, the stronger the relationship. So r squared is a great number that ties in the strength of the relationship that we see in one of these linear models. 73.33% is not bad, but it really focuses on what it tells you. And it's kind of like a script, just got to fill in the words. Typically, when we grade this, we're looking that you talk about the variability in the y. Don't just say 73% of the y values, because it's really more about the different y values. In the y values in this particular problem, because again, we got to do context, is the time it takes a customer to finish checking out. And that is explained by the variability. So notice I use the word variability again there, because again, not only are the y's varying, the times it takes to check out, but also the number of people in front of me is also varying. So having that word variability in there twice is actually really important. All right, the final question here says one of the data points was determined to be an outlier. Circle that data point on the scatter plot and explain why it's an outlier. Pretty obvious. I hope everybody sees that that's the outlier. So it does say to circle it. So I circled it. Now I got to explain why it's an outlier. So I estimated that this data point is roughly 3, 100. I mean, it could be even 3, 50. Again, it's 3, something pretty low, right? If I'm trying to estimate what that y value would be, I said around 100, but it could even be a little bit lower. But the point is this is an outlier because it does not fit in line with the rest of the data. For 3 customers, typo there, boy, I'm bad at spelling sometimes. That should be L-I-N-E, sorry about that. For the number of customers in line in front of the selected person, it took a very short amount of time until he or she was done checking out. So again, the data would say that for 3 customers, it should be somewhere up here in terms of how long, about maybe 600 seconds to check out, somewhere in that time frame. But this data point was not fitting that pattern. For 3 customers in line, it actually had a very low amount of time. Maybe it was the express line where everybody in front of them only had like 1 or 2 items, and they got through there real quick. I don't know what's explaining this outlier, but it clearly doesn't fit the pattern at all when compared to the other points. Again, the explanation in context would be that it's a very medium kind of numbers of customers in line, but a very short time to check out. All right, that's it. I hope that you agree this is a pretty easy question here, not overly difficult. And when you see a question like this on the AP test, you should kind of be happy. I think problems that deal with linear regression are actually quite easy. All right, that's it. Stay tuned for more videos over more FRQ answers.